Okay, let's look at an example from the 5.2 homework, and we're actually just going to look through one. And that's because, like I said in the concept video, a lot of the homework problems from this section are all very, very similar. It's just you using these same two formulas in different ways. But I wanted to focus on number 9 because number 9 really hammers home the difference between a continuous income stream and a traditional investment. So here we have grandparents Trent and Mackenzie that just had a new grandchild, Brenda. They want to create a trust fund so that on her 25th birthday, she'll have $270,000. Look at part A. What lump sum would they have to deposit now at 5.3% compounded continuously to achieve this goal? What does that sound like? That's not a continuous income stream. That's a one-time investment, meaning I'm going to use my kind of traditional formulas from up here. But is it asking for present value or is it asking for future value? Well, it's important to recognize that we want it to yield $270,000 on her 25th birthday. That's the future. So this represents a future value. And therefore, in part A, what am I solving for? I'm solving for the present value. But once again, just a traditional present value. This isn't a continuous income stream yet. So present value, I'm going to take my future value, 270,000, multiply it by E to the negative, my interest rate. We put a negative up there because it's present value. I want a decay function, multiplied by the number of years, which in this case is 25. And I get 71,766.80. What is this in terms of? This is, of course, money, because this is how much they would need to invest right now that the grandchild is born, so that they can have this amount in 25 years. But of course, what if they don't have that much on them? What if they're not that fluid and they don't have 71,000 that they can just invest right now? So in part B, we're going to look at that scenario. Instead, these grandparents decide to just invest a constant money stream in order to be able to achieve this goal. We're going to assume the same interest rate of 5.3%, but we're going to find R of T, or we're going to find that constant money stream so that the accumulated future value ends up being $270,000. Well, there's actually a couple different ways I could do this. I could do this using either my future value formula or my present value formula. In both cases, what do I plug in for R? Nothing. I don't know what R is yet. This is what I'm solving for. Well, if I'm using these formulas from above, I'm going to take R, divide it by my K, so 0.053. And then in parentheses, I'm going to have, if I'm using my future value formula, I'll have E to the K, so 0.053, times my fixed amount of time. Capital T represents that fixed amount of time, so 25 years minus 1. Or, once again, I could use my present value. Same thing, I don't know what R is, so the only thing that changes is the order and the fact that now I'm working with a negative exponent. So I can use either one of these as long as I recognize what to plug in for these values. Since R is unknown, I need to plug in something for my present value and my future value in order to actually be able to solve for R. So if I use my future value formula, what will I plug in for A? Here, I'm going to switch it over to the other side to make it a little bit more convenient. What do I plug in for A? What's my future value here? I want to eventually have 270,000 after 25 years. So that represents my future value. If I use present value, what number do I use for B? Well, that's what I did in part A. Part A is I calculated the present value for this specific future value. So I can just plug in 71,766.80. Now, I will say I did round to get that present value, which means the more accurate number is going to be from my future value because I'm not rounding. So let's go ahead and use my future value formula. I set it equal to 270,000, and now I'm ready to solve. Well, the first thing I could get rid of, I'm solving for R, right? So first thing I'll get rid of is I'll get rid of this 0.53 in the denominator. To do that, I'll multiply both sides by 0.053. This leaves me with 14,310 on one side, and then R times E to the 0.053 times 25 minus 1, all in parentheses. Well, at this point, I really only have this to get rid of, and it might be easier for me to simplify what's inside first. If I do that, I get r times 2.762185 ... So, to move on, I'll just divide by that value. You'll notice I kept as many decimal places as I could because I'm not done. I haven't reached my final answer yet. But that leaves me with 5,180, and if I keep 2 decimal places, I'm going to have 0.68. What does this represent? This represents that for the next 25 years, these grandparents need to contribute this amount, 5,180 and 68 cents, to this account every year. And if they do that, then it will eventually accumulate to 270,000 by the end of those 25 years. One thing that I forgot to mention is when I went through this process in Part B, you'll notice I used the simple formula that doesn't require integration. Why? Because once again, we're assuming that r is constant, that we're contributing the same amount. If we were to change that, this would get much more complicated. And so that's why you don't see me using the integration. I can skip straight to these formulas because I'm assuming r is constant. Perfect. So that's how I can actually use those formulas. Go ahead and try out the other problems. If you run into any issues, please let me know. Shoot me an email, and I'd be happy to help you. But good luck, and I'll see you in the next video.